Okay, this is how he did it. He said 1 to 100, I can't add that up. So what he did, he could add this up, though. Okay, can somebody explain to the class what he actually did there? Flipped them around, wrote it backwards. Then what he did, the charming 7-year-old boy, is he said, well, 1 plus 100 is what? 101. Lovely. What is 2 plus 99? Natural. What is 3 plus 98? Oh. What actually happens all the way through? They're all 101. Okay, so how does he add that up then? What does he do next then? There's how many? You sure there's 50 pairs of 101s? One more time, sir. Oh, he could have. He could have used 0 to 100. He could have used 0. But just the way it happened to work is that the first one's 100, the first one's 1, the last one's 100. Okay. How many sets of these are there? You sure about that? Just tell me if I'm adding from 1 to 100, there's 50 things. I think there's 100 things. So I'm going to say 101 times 100, which happens to equal 10100. I will have to eventually divide by 2. Why am I dividing by 2? Because there's pairs. There's 2 sets of everything, right? So because of that, it's going to equal 5,050. And he did this, and the teacher went, because the teacher just wanted 5 minutes of, just to think, to relax, post motivation. Okay, and that's what we're doing in this unit right now. This is our lesson today, is that. What a series is, if I can find my notes. A series is just the sum of the terms of a sequence. The sum of the first n terms is Sn equals T1 plus T2 plus T3 plus ... plus Tn. Right, so when I say Sn, that means the sum of the first n terms. So remember how on, what day would that have been? Friday? It was just like 1, 3, 5, 7. And today we're just doing 1 plus 3 plus 5 plus 7. That's the only difference between those two things. Okay, we're going to make the formula here right now, but I want to see what you guys can do and if you can use Mr. Gauss's method here to add these for me, okay? Example 1, I guess we'll do, or warm-up example 1, we'll call it. Okay, we want to get to a general term here eventually, but I want you to start just using using Mr. Gauss's method there first, and then we're going to confirm with your calculator. When I say confirm with your calculator, I mean we're going to add 3 plus 5 plus 7 plus 9 plus 7 plus 13. Okay, and figure out what the answer is. Then I want you to try Mr. Gauss's method that he used for this and see if it works. Okay, when we do that, let me tell you it will work, but I want you to try it the way we did it. Okay? Did it work? Do it then, Jared. I'll pause the video, so. Okay, all right, Joe, can you tell me what to write, please, then? I'm going to start with 3, 5, 7, 9, 11, 13. Go ahead, what do I do, please? Sorry? No, I want to do the Gauss method that we did in the other board here. Yeah, good. So what I'm going to do is I'm going to just write that as 13, 11. Yeah, and we'll get into that in a sec here for the general case. Okay, so all I'm going to do is write things backwards. 3 plus 13 is what? Yeah, so 16. So how many 16s are there? 1, 2, 3, 4, 5, 6. 16 times 6 divided by 2. Or I can divide by times by 3, but I'm just going to do it like this, divided by 2, which turns into 16 times 3 is 48. Is that right? Okay, using the football method, 3 plus 5 is 8, plus 7 is 15, plus 9 is 24, plus 11 is 35, plus 13 is 48. So that matches up. Okay. What I wanted to use is some nice numbers so we can do this for anything. Any questions on what happened here exactly, William? Go ahead. Okay, the whole idea about writing this backwards is that, so because I can't add all these numbers up in my head. I can, but I shouldn't be able to. Okay, what you can do though is I can easily add 3 and 13. What I want to get is I want to get all these numbers to be the same, so I can use these all the same to multiply. One more time, sorry. Oh, just because I'm adding, so I did the pair. 3 and 13 is 16. That's all I'm saying. Yeah, and that's exactly our general term, right? So what our general equation is going to be for the sum of a arithmetic sequence. I like what I like how you guys are into this. Okay, so what it's going to say is, William, do you want to say what you just said? You add the first and the last one. You add the first and the last. Perfect. What else do I do? What do I do here? Times by the number of terms. Sounds good to me. The number of terms is n. And I'm going to divide by 2. Okay, there's the equation. I'm going to leave a little bit of room here because we're going to give a different version of this. Okay, so leave a little bit of room. I'm going to say that n is the number of terms. T1 is first term. Tn is the nth term. And that's all I need for that. I'm going to make a new equation, so leave a little bit of room, please, for that. Let's say you don't have the value of the last term. How can I deal with this? Well, what does Tn equal? What's Tn equal to? In general, what does Tn equal to? What's the equation for Tn? Oh, goodness, we just did it. What's Tn? Okay, yes. T1 we can also call A, and Tn we can also call A plus n minus 1d. So I can rewrite my equation as Sn equals n times A plus n minus 1d over 2, which going back over here I can write as n times 2a plus n minus 1d over 2. Okay, so those are all my equations. When would you ever need that second equation? Right, if I say add up 1 plus the first 100 terms in the sequence 1 plus 3 plus 5 plus 7, right, then you do it. Or if I were to ask you at the attack game, there are 20 rows, 20 seats in the first row, 23 seats in the second row, 26 seats in the third row. If there's 25 rows, how many seats are there in the whole arena? Right? That would be the question. Yeah.
Can you do if you don't have the first term?
If you don't have the first term, we can do that too. Right? But we have to do a little bit more work. You have to do a little bit more work, but that'll do that. Okay. I'm going to hit stop on this, and then I'm going to do our first examples. Whoops. 9:30.